Sorry about the interruption. So we're gonna continue. Okay, so we're still on the net ionic equation worksheet. So this is the video two. So we after we write down the molecular equation, no matter what, you still have to balance them. Okay, so because we need to write the total ionic, we want to see what happened in my beakers, what's inside my beakers. So no matter reaction take place or not, I want you to show me what happened inside the beakers of the solution, like this kind of beakers. I want you to tell me what happened. Okay, so let's read this carefully. So we gotta use red pen. So first, you wanna look up. I have one Na. Okay, but they decompose. So you have to tell me what charge. Oh, Na, you already tell me that's Na plus, and Na is a plus. Okay, so I'm gonna write one Na plus, and coefficient and the atom with the state, and also tell me the state, the charge, and tell me the state. So one Na plus Aq. Okay, and then here decompose, I get one OH. OH what? OH minus, right? So plus 126 OH minus AQ. So you have to give me the charge. You have to give me the charge, coefficient, the charge, and the state. Next is this is AQ, so we also decompose. Okay, so I got one H. H what? H plus. One H plus AQ. And then plus one Cl. Cl what? Cl minus. One Cl minus AQ. So what I read on the first row is what happened on the left. Okay, now I'm going to move on to the second line, which is anything on the right-hand side of the equation with the arrow. Okay, now this is one NaClAq, so we also have to separate them because it's soluble. So one Na plus AQ, and then one Cl minus AQ. You have all your charges in the rainbow. Okay, so one Na plus AQ, and then one Cl minus AQ. And then now blue pen. Now why do I need to use blue pen? Because the H2O is liquid. I told you, any my product, PBT, gas or water in liquid, we don't touch them. We don't do anything. We just leave it. So blue pen, we're going to keep just right plus 1 H2O liquid. So before you cancel out any spectated ions, this is the total ionic equation, this TIE, before I touch anything. This is it. But then now we're going to use black pen to cancel my spectated ions. Spectated ions are the ones that they show up on both sides of the equation with the same coefficient, same charge, and same state of the matter. Okay, so if your coefficient is not correct, your charge is not correct, your state are not correct on both sides, you cannot cancel because you did something wrong. Okay, so let's check. Okay, now do I have one Na plus AQ shows up on both sides? Yes, we do. One Na plus AQ, one Na plus AQ, exactly the same. No matter coefficient, charge, and AQ, and the state. So we use black pen to cancel three things together. Three things together. Exactly the same. Exactly the same on both sides. Any other thing is the same? Yes, I do. I get one Cl minus AQ. I get one Cl minus AQ. Exactly the same. So cancel out and cancel out. That's it. Okay, so then after that, we're going to come up with using black pen. All right, we go to the net ionic equation, NIE. So net ionic is whatever left over. And please write plus first, negative next. So then on the left-hand side, I have 1H plus AQ first. Black pen, okay, we use black pen. So 1H plus AQ plus 1 parenthesis OH minus AQ. Let me see if I did something. Actually, you know what? I'm going to ask you to use red pen maybe. Let me see. What pen should I ask you to use? But I want to use red pen because people will mess this up. So red pen, okay? I'm sorry about that. Red pen. Yeah, because people cannot see the difference between AQ and the liquid. So sorry about that. This part, the red at the left hand side use red pen, okay? Left hand side use red pen. And then the right hand side, I'm going to continue to use blue pen because this is liquid. This is I precipitate out. So 1 H2O liquid. Okay, so the left hand side we use red pen, the right hand side we use blue pen. And this is my net ionic equation. Now be careful, my coefficient simplify. Sorry, it's red pen. Okay, my coefficient simplify. 1, 1, 1 is simplified. All right, now we're going to check 4 things. Okay, so here checking, I'm going to use black pen. So you have 4 things you're going to check. Okay, so the first thing is number 1. Okay, I'm going to write down the atom. Okay, I'm going to write down the atom thing. Okay, so I have H and I have OH. Okay, so we're going to show. Okay, well, how many H on the left hand side? I have 1. And how many on the right hand side? Let's see, did I do something wrong here? Oh, actually, I'm sorry. The left hand side, I have 2. The left hand side, I have 2. This is a special case. I'm going to use O then. I'm going to use O, okay? 2 hydrogen on the left, okay, because I have 2 hydrogen. You have 2 on the right hand side. Oxygen, I have 1 and 1. This is one way you can write. This is a special case because of water is a special case. You can write like that way. Or if you want, you can write like this way. I have 1 H on the left. And here you know OH and H. I have 1 H on the other side. And then OH, I have 1 OH and 1 OH. So either way is fine. As long as you see them, they're balanced. Okay, so here I'm going to use 2 H because 1 H here and 1 H here. And then here I have 2 H. So totally 2 and 2. And then oxygen, I have 1 and 1. So you can tell that it's balanced. So check mark. Okay. And then number 2. I want to check the positive and negative. So positive and negative. Okay, so what happened to positive is I have 1 H, right? So 1 times plus 1, I get plus 1 from here. And then on the here, we get 1 times negative 1, I get negative 1. And they add up to 0. They add up to 0, so which is good. Okay, and then number 3 is we cross over. Okay, so I got H plus, so I put the coefficient, like the charge back, and then OH 1 minus. And then when you cross over, you will get H, you will get H2O1, so you will get H2O. Okay, it's also good. Okay, and then finally, you want to tell me what happened in the double displacement condition is on my reactant, I got H plus AQ, and then my OH is also AQ, right? It's also AQ. Okay, so H plus is AQ, OH minus is also AQ. And then what happened to my product? My product, I get H2O, which is liquid. So my double displacement condition met. Okay, so this all 4 things are good. So then that's my answer. Okay, now let me show you number 2. So number 2, beryllium iodide and copper 1 sulfate. So if you check the solubility, you know that they are aqueous. Okay, so red pen, beryllium is Be2 plus, and then the sulfate is parenthesis SO42 minus, and then when I draw the rainbow, and I bring the cloud here. So Be2 plus, Punic is SO4 2 minus in the cloud. And then for the name, I just write beryllium sulfate. Right, that's right. That's a red pen. And then the green pen, here I got iodide, and then I got Cu plus, okay, and then rainbow, and then when I bring them to the cloud, make sure they're positive first, negative next. So then the name will be just copper 1 iodide. So green pen here. So copper 1 iodide. Okay, now go ahead to start to do the equation. So coefficient box, here we cross over. We got BEI2 AQ plus. We'll cross over here. Okay, so we got Cu2 SO4 AQ. And then arrow. Okay, now we can start. We need to start to be careful. We go to the product. So beryllium sulfate. So we check sulfate. Okay, we check sulfate. Sulfate is soluble, no exception. So beryllium sulfate is AQ. So we can use red pen now. Okay, so will be Be SO4 after you simplify is AQ. And then copper 1 iodide. So we want to check it's soluble. So iodide is soluble, no exception. So we also use red pen. We also use red pen. So then will be CuI and it's AQ. Okay, so we know first of all there's no reaction. We know that. So I'm going to use black pen to write no reaction in the arrow. But we still go ahead to balance the equation because we want to find out what's going on in the beaker. So after we do the balancing, we got 1, 1, 1, 2. 1, 1, 1, 2. Okay, now we go ahead to separate down aqueous. Okay, so I got 1 BE, and the B is 2 plus AQ. 1 BE, 2 plus AQ. I got 2I minus AQ. 2I minus AQ. Plus, I got 2Cu plus AQ. I got 1 SO4. SO4 what? SO4 2 minus AQ. 1 SO4 2 minus AQ. So this is what happened on the left side. Okay, we got to go to the row 2. Down row, we go to the right hand side. So here I got 1 BE. 1 BE 2 plus AQ. Because why do I need to separate? Because the AQ. So 1 BE 2 plus AQ. Okay, and then I got 1 SO4. SO4 2 minus AQ. 1 SO4 2 minus AQ. And I got 2Cu plus AQ. And I got 2I minus AQ. Okay, so this is the total ionic. Now we got use a black pen to double check. Even though you know there's no reaction, you might cross over wrong. You might balance the equation wrong. Okay, so you want to double check, is everything, 3 things matching? It's a coefficient match, it's a charge match, and it's a state match. 1B2 plus AQ, 1B2 plus AQ, everything match, we cross it out. 2I minus AQ, 2 minus AQ, 100% the same. Okay, now let's say again, if you get 2I minus here, but you get 1I minus, you know you did something wrong. You cannot cancel. Instead, you should go back to check your crossover or balancing. Okay, 2Cu plus AQ, 2Cu plus AQ. And then 1SO4 2 minus AQ, 1SO4 2 minus AQ. So before the total ionic, it tells you what happened in the beaker. Well, after you cancel out the spectator ions, we get nothing left over. So you can use black pen to say, on the not ionic, you can just write black pen, no reaction, no reaction. And then check, how do I know it's a no reaction? The check for no reaction, you don't need to list out these 4 things because you can just write no gas, PPT, water is produced. Okay, so all you need to write just that. All right, so now let me go to the back, to the number 3. Okay, so number 3, tin 2 nitrate and then sodium carbonate. So we gotta write tin. We know that the 2 reactants that I gave you are AQ, okay? So you don't have to worry about checking. They are AQ, the reactants. So tin 2 is SN2 plus. And carbonate is parentheses CO3 2 minus. So I'm going to draw a rainbow and then bring them to here will be SN2 plus parentheses CO3 2 minus. Okay? And then we can just write them tin 2 carbonate. Right? And then green pen, nitrate is parentheses NO3 minus, and then sodium's Na plus, and rainbow, and bring them to the cloud. Again, positive go first. Na plus, parentheses NO3 close minus. Okay, after we draw the rainbow, and we can just write sodium nitrate. Okay, again, it's positive go first, not the array. Don't give me nitrate sodium. Okay, must be positive go first. Okay, so we write like this way. Okay, now we go ahead to check. Okay, we know that the 2 reactants that I gave you is aqueous. Okay, so here we cross over, we got Sn. So the bracket, the coefficient, Sn parentheses NO3 close to AQ plus line the blank, so Na2CO3AQ. Okay, arrow. Now you have to be checking tin 2 carbonate. Okay, it could be aqueous, could be precipitate. So carbonate is insoluble. Carbonate is insoluble, no exception here. So we have to use blue pen because it's a PPT. So after we cross over here, we will get and simplify, and we get a blank SnCO3. Okay, we use, oh God, I'm using blue pen. Okay, blue pen. Okay, it's a blank SnCO3 and then PPT. And then next is sodium nitrate. So sodium nitrate is soluble, no exception. So we use red pen. So blank NaNO3AQ. All right. Now we have to balance them. We get 1, 1, 1, 2. 1, 1, 1, 2. All right. 1, 1, 1, 2. So that's the molecular equation. So now we can separate them. Okay. So this AQ, we can separate them. I get 1 SN. SN what? SN2 plus AQ. So 1 SN2 plus AQ plus. I got 2 Na3. What charge? Na3 minus AQ. So 2 parentheses NO3 minus AQ. This is also AQ, so we separate them. We got 2 Na. Okay, 1 times 2 is 2. 2 Na, Na what? Na plus AQ. 2 Na plus AQ. And then I got 1 CO3 2 minus. So 1 parentheses CO3 2 minus AQ. So this is what happened on the left hand side. and then we go to the right hand side. Okay, now this one is the PPT, so we can't touch them. We have to just copy them. 1SnCO3 PPT using blue pen. 1SnCO3 PPT. Okay, and then this we're going to separate. So 2Na plus AQ. So 2Na plus AQ plus 2NO3 minus AQ plus 2 parentheses NO3 minus AQ. So this is what happened on the right hand side. Now we use black pen to cancel my spectated ions. Okay, again, double check coefficient, charge, and the state. I don't have SN2 plus on both sides. I do have 2NO3 minus AQ on both sides. So black pen, cancel the three things. I do have 2Na plus on both sides. I don't have one CO3 2 minus on both sides, so leave it. Okay, then the ionic will be left over. Again, plus first, negative next. So I'm going to write SN2 plus AQ plus 1 parentheses CO3 2 minus AQ, and then arrow, and then blue pen, I got 1 SnCO3 PPT. Now again, make sure that the coefficient are the simplified. If you haven't simplified, you have to simplify because it will affect my checking. So black pen, I'm going to say that I do have reaction. So I'm going to put a check mark here. I do have reaction. So then checking would be 4 parts. So number 1, I put the Sn and then CO3. Okay, so we double check. Okay, so I do have one SN, and one SN for both sides. And then CO3, I have 1 and 1. So this is good. Okay, so now second. Okay, what happened to positive charge? The positive charge, I get 1 times plus 2 from the Sn. So 1 times plus 2 equals plus 2. Okay, and then for the negative, I have 1 times minus 2 from the CO3. So 1 times minus 2 equals minus 2, and they are adding up to 0, which is good. And then the 3. Okay, I have to cross over them. So I get my SN2 plus, and then my CO3 2 minus. We cross over. So SN2 plus, parentheses CO3 2 minus. Okay, I cross over. I will get SN1 parentheses CO3. Okay, I'm sorry, SN2 parentheses CO3 close to, but then I have to divide by 2. I get SN1 parentheses CO3 1. So finally, I get SnCO3. Okay, so number 2 is good. Number 3 is good. It match with my name. Okay, and then number 4. Oh, I don't have room here. So number 4 is my reactant. Okay, I do have room on my answer key. This is the answer key here. So you can write like that way. Okay, so I'm going to try to write it. SN2 plus is AQ. My CO3 2 minus is AQ. And then my product is SnCO3, which is PPT. So which is also good. Okay, it's also good. So when I put my answer key on, I write a little better like this way, so it won't cut off anything. This is it. Okay. All right, now let's do number 4. Okay, so chromium 2 nitrate and iron 2 sulfate. So chromium 3 Cr3 plus, and then sulfate parentheses SO4 2 minus. Draw the rainbow, bring them to the cloud. Cr3 plus parentheses SO4 2 minus. And when I name them, just chromium 3 sulfate. Okay, and then green pen. So nitrate is parenthesis NO3 minus, and ion 2 will be Fe2 plus. Okay, draw the rainbow, and then bring them to the cloud, Fe2 plus, and then NO3 minus. Again, positive first, negative next. And the name will be just ion 2 nitrate. And you can also tell it from the cloud too. Okay, now we can start to write down the molecular equation. So here we cross over coefficient and then C our parenthesis NO3 close 3 AQ plus line FeSO4 AQ. The first two are reactants. And then next we're gonna double check. Okay, chromium 3 sulfate. So sulfate are soluble, and I don't have chromium here, so it's soluble. So we use red pen. So line Cr2 parenthesis SO4 close 3 AQ, and then iron 2 nitrate. So iron 2 nitrate. So nitrate is soluble and no water, no soluble. Okay, so we're gonna use red pen too. Okay, so Fe parenthesis NO3 close to AQ. Okay, so we know that there's no reaction. We know that there's no reaction, but we still need to, so black pen here, but we need to show the coefficient is 2, 3, 1, 3. Okay, 2, 3, 1, 3. Now we're gonna go ahead to write down 2Cr. I got 2Cr, Cr3 plus, 2Cr3 plus AQ. Here, 2 times 3 is 6. 2 times 3 is 6 nitrate. Okay, I got 3 Fe2 plus. I got 3 SO4 2 minus. Okay, so this is the top part, the left side, the right hand side. We also have to separate them. So 2 Cr3 plus AQ and 3 SO4 2 minus. And 3 Fe2 plus. And 3 times 2, 6 nitrate. Now, if you did not balance correctly, let's say you get a 1 here, okay? So you know that the coefficient doesn't match, and then it won't be canceled because your coefficient is not matching. So you know there's something wrong, okay? I got 6. This is NO3 minus AQ. Okay, now you can double check. All right, double check. Black pen. So TCl3 plus, it shows up on both. 6NO3 minus AQ also shows up on both. 3 Fe2 plus AQ shows up on both. Again, you have to check 3 things altogether, like the coefficient, the charge, and the state. And then 3SO4 2 minus also shows up. Okay, so then now you can use the black pen to write the net ionic is no reaction. Why? It's because no gas, PPT, or H2O liquid is produced.